Chris McDonough, I don't know if I can pronounce his name, my mentor in Google Summer of Code back in the days when I was learning to code, and a dear friend from many years ago. We used to hang out in Python times. Asked me to record a video, and I tweeted that, or Xed and Mastodon, that using Copilot and strongly typed language, in this case Haskell, is kind of God mode of programming. So he said, okay, record a video. And funnily enough, I was just looking to kind of write a Haskell small library which just wraps around fn match C library, C function. And this function kind of, you give it like a string of paths where you can use like asterisks and question mark and so on, kind of a globbing syntax, and it will tell you if the second string you pass matches that or not. So I thought, okay, let's use this opportunity to see if I can showcase a bit of that. So first I will use ChatGPT to kind of, Copilot, ChatGPT, same thing. And yeah, first I like to ask it a question to help me guide how to design the whole thing. Not that I wouldn't know how to do it, it just saves a bunch of time. So let's see. It's annoying that this button is kind of covering. Okay. I'm still learning how to use Loom. All right, how would I implement our Haskell library that exposes Haskell API for C function fn match? So let's see. It should tell us more or less. Okay, this is the type signature. So as I said. Oh yeah, and it accepts the third parameter, which is kind of like some global flags you can pass it. All right, so it says we need to create FFI, and we need to create this foreign kind of signature. This kind of helps us map Haskell types to CMAP types. And then there's the implementation. It says we should think about testing documentation. All right, one thing I just want to change here is we want to use a byte string. So in Haskell, a string is basically a linked list, which is super slow. So you want to use byte string if you want to write code that's actually reasonably fast. So let's see. It should be more or less the same, except it will import the byte string stuff. So meanwhile, on the right side, nowadays I always start projects with Dev.env. It kind of provides the environment. So all right. So here it gives me stack and also Cabal. By default, I enable Haskell and I tell it which compiler to use, and we're going to use the Ormolu pre-commit hook, which will format the Haskell code. So let's open up the terminal. And well, let's first activate the environment. That will give us all the Haskell bits we need. All right. And now let's create a data structure. So we're gonna So Cabal is the kind of the package manager for Haskell. So we're just gonna tell it to scaffold the thing. Don't override. We will use the latest Cabal. Match sounds good. Version sounds good. I always use Apache, so let's use Apache, which is number 3. Let's use the one caches.org. The homepage. Might see wrapper. Pretty boring. Right. What system? The hell do I know? Let's pick system. Source with the library. Let's just delete the GHC. To generate a test. Yeah, let's have a test case. Yes. Any questions? No. All right. That should give us a nice thing. So let's see. I also use stacks. So we're just gonna quickly run a stack here. There you go. We have a scaffold. Now, oh yeah, the only thing I'm missing is I need to enable, so Devon provided the Haskell language server as well for the matching compiler that you pick. The only thing you need is I also need to install the .env file, which I forgot in the beginning. Let's see, .env, this one. So we're gonna create .env rc this. Right, so now if I enter this project, I should be able to get Haskell environment. Let's see if it really works. Oh yeah, we need to allow it. Let's see. Let's see if it works. Yeah, let's go. Yeah. All right, so we have Copilot completing, and we have Haskell language server, which will show us the errors. All right, let's go back to what GPT is saying. All right. All right, so this is kind of the code that will declare the wrapper and then expose the Haskell bit. And it's gonna use the byte string. So let's first say here. Let's call it match. And we're gonna use base, and we're gonna use byte string. So we can already see that it's completing Cabal stuff as well. Now I don't know exactly in what kind of file this we need to save this, but let's give it a go. Just put it here. All right, this needs to go at the top, and can export a match. All right. Name the library match. Right. See if I build this now. Yeah. Match. All it's gonna. All right, that seems to work. Um, right. So, well, I could have just kind of coded it here, but I guess using ChatGPT is always more fun. So yeah, it's using the unsafe function to get us from byte string to C string, which just essentially goes through bytes and gives you as is, and then pass this. The first argument is a byte string translated to C string, and the second one as well. And then here we pass in the flags, and we check that the result is 0. Uh, to to confirm that it matched. Let's see what ChatGPT is saying. Yeah, proper handling. All right, so this kind of unsafe means it does not check if the byte string is null terminated. So we're just gonna trust that it is, and it will. It also doesn't allow that the C and FN match will what is it? Yeah, it doesn't allow FN match to manipulate with it. It shouldn't change the structure because it gives direct memory access. And what else do we have here? Right, the Haskell wrapper. We need to, here it says we need to link to FN match. So let's try. If we go here, I have no idea if we need to include something here, but what I would say is like include FN match and C sources. All right, probably we do need to ship FN match with it. And then if we go to the tests, is each unit. This is how I kind of guide the whole thing with comments, right? That's the whole idea. So I need to do a bit more importing here. Suit all depends on base and also byte string. And I actually have H unit H spec. Oh, I don't remember. H spec. Yeah, I think it's H spec. It's the one. All right. Let's see what it wants us to do here. Right, that fails. So here we go. We have a test that matches a pattern, and yeah, it's doing some silly stuff here. Let's use strings. All right, that should work, and that should be false. So, like, actually, test cases are a perfect example of that. I can say here, yeah, it's trying to be lazy. Pattern with and so let's see if it needs a bit of help. There you go. Let's split that up actually. There you go. So now we can run the tests. It seemed to fail. That doesn't. Oh, it's packaged with the small one. All right, there you go. All right. Oh, and we don't need to import byte string. We just need to add the extension here. There you go. All overloaded strings, just as Copilot predicted. There you go. And right. Right, so here we go. Here it's saying that IO bool does not match bool. Let's check back. Let's see. Ideally, we wouldn't be doing this in IO because it's just matching, but probably we have to use IO of the unsafe. I think here is what you would probably use the unsafe function, which performs IO without. Let's see if we can do that. Unsafe before IO. Perform IO. There you go. Right. So this is like the ultimate escape hatch in Haskell. If you have a function that IO, you can kind of cheat and tell it not to use it, and it's very typical to use it inside when you grab C functions because you need to do IO to perform a bunch of stuff, but then the actual library, the actual function doesn't do any IO. So, all right, let's run the test again and see if it fails. Let's fail. Oh, I thought I fixed this. All right, let's go full screen. So I fixed this. There you go. It passes. There you go. We implemented the F1 match, and it does pass our tests. So let's code a little bit more. So what we want to do also add is not just a test suite, we want to add a benchmark. So there you go. It auto-completed the benchmark for us. It says that we expect a bench folder, bench, and inside there should be name.s. Usually criterion, yeah, that's the one. There you go. Already completed all the benchmarks for us. Let's add a bit more. Bench along. String. Oh, all right, sometimes it needs a bit more. It's a long string. There you go. This will replicate a, let's say, 10,000 times. That should be enough. Just to see that it works well. All right. So if we run stat bench, well, let's see if I saved this and the Cabal file as well. Has criterion here, so that should work. All right. Bench. Benchmark. Yes, benchmark. I guess not bench. All right, that works. For some reason, I pressed space too fast. Otherwise, it would have guessed that we need a benchmark there. Went up to completing. All right. Now it needs to install Criterion, which is the benchmarking tool in Haskell and all these dependencies. So that's compiling all the stuff. And we should have a nice benchmark of our little function here that will kind of show that it's hopefully a few milliseconds of time on average spent running the whole thing. I wonder if there's something else I could show meanwhile. I don't know. Like ChatGPT wrote the whole function for us. So there's not really a lot that we needed to do. And it kind of showed us that we want to get rid of the IO. Let's see. Benchmark failed. Replicate. Right, so this is, it needs to overloaded strings. Let's save this once and for all. So there's this section here, which is applied to all the other sections. And you can say default extensions related strings. And then if we go to the tests, don't need it anymore. Here, now it will be applied to all of our programs. It still fails. Oh, right, it's because we're using replicate. Let's see. It's weird that didn't warn us. Oh, that's why. Multi-credible. Right. So this is a bit of an annoyance with the. This is a bit of annoyance with the Haskell language server. Once you have multiple, I guess, components with the same module names, it kind of stops working. Let's see if I remove the tests. I don't know how to fix that correctly, but let's see if I just remove this. Maybe it will. I removed too much. Just give me a second. Right, we just want to remove the test sheet. I hope that we can get type checking out here. It will not work. All right. So this is an edge case where it starts to break, unfortunately. Let's just, while we're at this, let's move all the common stuff to the warnings and remove the bits that are not needed here. Just like this. And we can also add and base byte string. Remove it from here. Remove it from here. And we can remove it also from here. Right. That simplifies the whole thing a bit. It's funny it asks you not to generate these comments and you tell it not to, but it still does. Anyway. All right, so we don't get the guidance here anymore, um, which is this didn't work, but I think probably the byte string model should have to replicate. So let's see if my guess is right. Seems to be. Oh, well, it's complaining about. Oh, build depends. Builds depends, but build depends. All right. Let's see. Let's run the bench. All right. Now it's using the correct bits, but it expects a single byte instead of a character. It's a good point. I never thought about this. Shouldn't that also apply to characters, the overloaded strings? Or it is not? Let me just double check this. Okay. I always forget the syntax. Oops. No. This is a great example of get a syntax, you can use the Copilot help you out. I don't know why it was coloring it wrong. All right, let's. It seems it doesn't. It doesn't work. All right. Let's see if we delete this. It's got smart. It used the integer for it. All right. Here's a good example of how it Copilot can help you cheat, at least to get things running. There you go. We have the benchmark running, and it seems like it takes about 6 milliseconds to match. And that's it. Where is the one with the long pattern? Actually, that's the one. Doesn't match. Matches a pattern. Mhm. Oh yeah, here. Matches a long pattern. Right. What if it's something different? Yeah, it's funny how it just uses an integer here. There you go. Implements the benchmark. So let's add a README. All right, that's it. All right, I think that's about it. Maybe it's not the best case for showing how nice it is, but you have Copilot how to generate code for you, and then you have um, Haskell giving you type errors, and literally if you like add that error as a comment, Copilot will kind of guide you further. Which is really cool, I think. Um, let's maybe just add these things to the next slide so it's a bit readable. I'm gonna try to guide it to not use an integer here. Let's see. So the way it works is like it generates some stuff wrong, and then you write a comment like this. Oh, let's see what it generates now. Yeah, it still wants to do that. Nope, doesn't want to listen. Use pack from string. Let's see. Yeah, now it's trying to be clever. It will generate a string and then convert it all to byte strings. You can also per control enter, and it will give you more options. And that can give you the. So actually, if we remove this comment, which doesn't seem to help, we will already get a bunch of suggestions. And maybe one of those is. All right. I guess let's go with this one. So yeah, this is maybe a good presentation of how sometimes it's a bit hard to get it to do exactly what you want. So in that case, you just use the old way, which is go to the byte string. You figure out how to pack a single byte. Yeah, char8. And this is, and that's it. I think that's the. Check. Ach. Port 8. Two from the base. I always forget where you have that function. Singleton. There you go. That's exactly what it's using here. Let's check. Google. I don't know. I just leave it as it is. It's a bit sad that this doesn't work. I would expect overloaded strings to I also do characters, to be honest. Uh, but it does say strings, not characters. So I guess. Fine. I think that's it. Let me know if I should expand on something.